Welcome everyone. Let's begin our lesson for today by going over the learning goals and success criteria. First, what are we learning? We're learning how to recognize all numbers as being part of the number system, to determine which number set within the number system a number belongs, to recognize that numbers can belong to multiple number sets at the same time, to recognize closure of number sets within the number system under mathematical operations, to recognize the relative position of rational numbers on a number line, to compare rational numbers and order them from least to greatest, to find the exact location of a rational number on the real number line, to use the location of rational numbers in order to find the location of 1 on the real number line, to convert decimal values including repeating decimals to fractions, to convert fraction values to decimals, to formulate logical mathematical arguments in order to prove mathematical principles, to prove the closure of rational numbers under mathematical operations, to recognize that all real numbers can be factors of all other real numbers, to recognize that numbers do not have to divide evenly in order to be considered factors, to critique the work of others and examine multiple methods and techniques to solve problems, to determine the best course of action when completing problems and recognize that it is important to have multiple techniques to solve a problem, to determine the placement of various numbers on the real number line, to find the relative position of real numbers that are undergoing mathematical operations. How are we learning it? Through the Reasoning with Rational Numbers review notes and the Reasoning with Rational Numbers review assignment, as well as the Reasoning with Real Numbers review notes and the Reasoning with Real Numbers review assignment. When can we use this information? To perform simple calculations such as a budget by recognizing boundaries of numbers to determine if adding the items in your budget will stay within your income amount. To cut boards into smaller equal pieces in order to create or repair furniture. To organize thoughts and ideas about any topic in order to provide a valid argument for your thoughts, beliefs, and ideas. To recognize that there are an infinite number of solutions to every problem and that the most important factor in solving any problem is to find the best approach. To organize thoughts and ideas about a topic in order to provide a valid argument for your thoughts, beliefs, and ideas. And to organize thoughts and ideas according to a given structure, such as planning out the events of a day based on time, duration, and number of tasks. How do you know you learned it? By getting a score of 4 on the Reasoning with Rational Numbers review assignment and a 4 on the Reasoning with Real Numbers review assignment. Now let's take a look at our agenda for today. We will begin by going over the learning goals and success criteria. While we do that, you'll fill out your Get It Started. Once you've completed your Get It Started, we'll go over it together and answer any questions that you may have. Next, we'll do our weekly raffle. After that, we'll go over the Reasoning with Rational Numbers review notes and the Reasoning with Rational Numbers review assignment. Once you've completed your Reasoning with Rational Numbers review assignment, we'll go over it together and answer any questions that you may have. At the end of class, we'll go back over our learning goals and success criteria while you fill out your Before You Go. Your only homework for tonight is to work on the Reasoning with Real Numbers review assignment and any incomplete assignments that you may have. Let's take a look now at the Reasoning with Real Numbers review notes. The notes begin with the learning goals and success criteria. First, what is a factor? A factor is any number that can be divided into a given number. For example, is 3 a factor of 36? Well, we know 3 goes into 36 12 times, so it is a factor. Now the question is 7 a factor of 36? Here's what I want you to get out of this. Every number except 0 is actually a factor of every other number, because every number can be divided into every other number and create a result. For instance, I can multiply 7 times something to get 36. Now, it may not be an integer that I multiply it by, but I can multiply it by something and still get 36. So, can I prove that 3 is a factor of 7? Well, that means 3 times some number is equal to 7. So, if I divide both sides by 3, I get that x is equal to 7/3. So, if I multiply 3 times 7/3, I get 7. So, 3 is a factor of 7, it's just not an integer factor of 7. So every number can be a factor of every other number. Is e a factor of 6? Well, I can do this and say e times x is equal to 6. Well, I divide both sides by e and I get x is equal to 6 divided by e. So if I multiplied e times 6 over e, I get 6. So e is a factor of 6. It's just not an integer factor of 6. So what I want you to get out of this is that every number except 0 is a factor of every other number. We can multiply by something. Now, it may not be pretty, but we can multiply by any number and get some other number. So every number is a factor of every other number except for 0. Now let's talk about the types of true statements. So there's 3 types of true statements. The first one is always true. A statement is always true if there are no examples that can make it not true. So for instance, the sun comes out today. That's always true. It may be kind of overcast, but the sun is still out. So that's an always true statement. Sometimes true means that there are examples of it being true and examples of it not being true. So we can provide examples on both sides. And then never true means that there are no examples when this ever happens. So, for instance, the sun comes up in the morning. Well, we know that that's always true. The sun always does come up. So that is an always true statement. It will be raining tomorrow. Well, maybe it rains tomorrow, maybe it doesn't. It's possible either way. So that is sometimes true. And lastly, the temperature tomorrow will be 200 degrees Fahrenheit. Well, sometimes it might feel like it's 200 degrees, but it's never actually 200 degrees. So that is never true. Let's look at some mathematical examples of true statements. So the first one says quadratics, which form the U shape, increase infinitely. Well, that's true as long as the parabola is opening up, right? That means it's going up forever in both directions this way. But if it's opening down, now it does stop here and it decreases infinitely. So this is sometimes true. Now, absolute value functions have negative y values. Well, remember, absolute values form the v. And remember, if we have an absolute value, it can't go below the y-axis. So it can't have negative y values. So this is never true. And linear functions have both positive and negative y values, meaning that it's going to cross the y-axis. Well, we know that anytime we have a line, it's always going to cross the y-axis, so therefore that is always true. Some mathematical operations in words that you'll need to know. Sum means that we are adding, difference means that we are subtracting, product means that we are multiplying, and quotient means we are dividing. Some mathematical examples of true statements. The sum of a rational number and a rational number is rational. Well, basically what that's saying is, if I add 2 fractions together, is there any way to get something other than a fraction? Well, we know that we can't get pi or e or square root of 2 by adding 2 fractions together, so therefore this is always true. The sum of a rational number and irrational number is irrational. Well, if I add a fraction plus pi, I will always have that pi, and because they're not like terms, so I can't add them together, so it will always stay irrational then. So that's always true. And the sum of an irrational number and an irrational number is irrational. So if I add pi and pi, I get 2 pi. Well, that's irrational. So it's at least sometimes true. But what if I add pi and negative pi? Well, if I add those 2 together, I get 0, which is not irrational. So therefore, this is sometimes true. What is the real number line? The real number line represents an infinite line that represents all real numbers. So note that all real numbers can be plotted on the real number line. So even pi, e, square root of 2, any of those numbers can be found on the real number line. The only numbers that can't be found on the real number line are complex numbers or imaginary numbers. So recognizing relative position on a number line. So I have x and y here, and x is smaller than y. And if we look at the distance here, it's kind of close to -2, but both are between -1 and -2. So if I wanted to find the product of these two, so product means multiplication, right? So if I wanted to multiply this, so let's multiply 2 numbers together and kind of check this. So this one's kind of close to -2, and this one's kind of close to maybe -1.5. So let's go ahead and multiply. We know that when we multiply 2 negative numbers, it's going to be positive, so we know it's going to be over here somewhere. And if we take this and say, okay, it's kind of close to -2, so -7/4 is close to -2, and this is about -1.5. So if we multiply those together, we get 21/8, which is a little over 2. So we would go to 2 and then go a little further and plot our point somewhere over here. This is where our product would be. And we can look at several more examples of this. So here we have two numbers. This time they are both between 0 and -1. Well, again, we know that they're both negative, so it's going to be positive. And they're both between 0 and 1. So let's try -3/4 and -1/2. Now that's not exact, but we're going to just try those two numbers to see generally where we're going to end up. So when we multiply them, we get 3/8. So it's going to be really close to 0 here. So somewhere right in there should be my product. Now we can do the same with quotients. So we have these two here again, and we know that when we divide them, it's going to be positive because a negative divided by a negative is positive. So we're going to use what we had before. So we called this one -7/4 and this one -3/2. And when we divide them, we get 14/12, which is really close to 1, just a little bit past 1. So it should be somewhere right around here. Now what about this one with the two numbers between 0 and -1? Well, again, should be positive because when we divide two negative numbers, we get a positive. So it should be over here somewhere. And we use -3/4 and -1/2. And when we divide them, we get 6/4, which is a little more than 1. So it should be somewhere like here. Let's take a look now at the Reasoning with Real Numbers review assignment. The assignment begins with the learning goals and success criteria. If we scroll down, we can see the questions. So it says, which of the following is not a factor of 7? Well, if we remember back to what we learned earlier, we know that every number other than 0 is a factor of every other number, so all of these are factors. Then we'll scroll down. This one says, is this following statement always, sometimes, or never true? The sum of two numbers is larger than each one of the numbers. Well, if we add two negative numbers, we know that we're going to end up with a number that's smaller, so that is not true all the time. But we also know that if we add two positive numbers, the result is going to be larger than the two numbers. So it is sometimes true. So we'll continue to answer each of these questions until we get to the end. Once we get to the end, we'll click Next. This will take you to your Before You Go. Go ahead and fill out your Before You Go and then submit your work on Google Classroom.